Okay, so this is going to be an unusual week. You remember your testing starts tomorrow. If you are testing, I believe it goes algebra, then you go history, and then biology. I think that's the order. If you're not testing, then of course you have the morning off, but make sure you know what the schedule is going to be. I have it up here on the board. The tardy bell for the first period will be 1:21. Okay, so you want to make sure you're in your first period class tomorrow by 1:21. In fact, tomorrow, the afternoon will be periods 1 through 4. Wednesday is 5 through 8. Thursday is 1 through 4. And then Friday will be a normal day. So your classes are about 34 minutes each, so a little bit better than during the STAR English exams. But just kind of big picture, 2 weeks from this Friday is the last day of school. Okay, we are going to be done. We got less than 3 weeks. So that means, the number of grading opportunities is starting to shrink. So next Friday, the 17th, you're going to have your second exam. Okay, so we want to be looking forward to that. I've already started putting it together this morning. That is going to have hyperbolas and parametric equations on there. We're going to have another quiz based on the focus activities. You'll get, because I'm not going to see you, well, actually, no, I will see you guys tomorrow, so you'll get the next focus activity then, and probably the fifth one later in the week. So you have that. We'll probably have the homework on parametric equations, and I don't know how far we're going to get with polar coordinates. So there are not a whole lot of grades left, especially if you happen to be a senior and your grade is a little low. Definitely take care of that stuff as soon as possible. I mean, I'll still be here in the morning. I am administering the algebra test in here. So if you need to come in for anything, I'm probably going to be setting up. I could probably take a minute to help you out as well, but just to let you know that. Wednesday should be fine if you're coming in for tutorials. And then Thursday morning, I'll still be here in the building, but they're actually having me test in another room. So I'll be around someplace. I think that's pretty much all I have, unless anybody has any questions about what's coming up. Okay, then let's talk about some parametric equations. We started looking at these on Friday, and we were able to graph several of these, but what were they? Hello? Okay, so let's see here. Vivian is here, Zach is here, and they're all here. Okay. Did they need to talk to you real fast? Okay, Zach, Jack, and Savion. These young ladies were needing to speak to you just real quick. Okay, there's Savion. Jack. Zach. Okay, so parametric equations describe the horizontal and vertical movement of an object with separate equations in terms of time. So we are taking a normal equation that has just x and y, what we call the rectangular equation, and we're going to introduce a new variable. This variable is t, it's called a parameter, and it's based on time. So the parametric equations kind of give me a bigger picture idea. It lets me know more of what's happening. X is going to have its own equation with t, y is going to have its own equation with t, and these specifically will tell me how far horizontally an object has moved with respect to time, or vertically what the height is with respect to time. That's what the parametric equations are going to help me do. And what we did Friday was, after we talked about those, we started graphing them, and everybody seemed to be doing really well. You were just taking values of t, plugging them into your two equations, obtaining the ordered pairs. Now, what are those arrows? That's the direction. Now, what do we call that mathematically? The orientation. There we go. That's the direction that the object is moving. How did we determine what direction to draw those arrows on the graph? Jane, what do you think? There you go. When we created the table, remember we always start with whatever values of t we're going to use, you always list them. What was that? Oh, we're always going to go ahead and list them from the smallest to the greatest. Did sound like a cricket. So if we do list my values of t from the smallest to the greatest, the ordered pairs that are resulting from that, the order in which we plot those, that's the orientation of the graph. Okay, so in here we got 21, 2 for the smallest value of t, 14, 2.5 for the next value. So the order in which we plotted those, that's the direction we're drawing my arrows. Remember, that's the orientation. And then we finished up on Friday. This is the second part of the lesson where we want to take a pair of parametric equations and we want to rewrite them back into the original rectangular form. Basically, that means we want to eliminate the parameter. We want to get rid of the t. We want an equation with only x and y. And we did that by substitution. You can either choose the horizontal equation or the vertical. Does not matter. You solve for t, and then you plug that into the other equation. My recommendation is use the horizontal, okay? Solve t in terms of x, because your rectangular equation will then already be y equals. We always want our rectangular answers to be y equals, what we're accustomed to. Okay, so let's try some additional examples. Okay, like for example, let's do this one here. Now, these are not in your packet. These are just some additional examples that I'm going to go ahead and provide you. Now, the next example in your packet that we are going to do is this one right here. Okay, but I want to go ahead and get a few extra before we take a look at that one, because that one's a little more involved. Okay, so we have x equals t plus 3 and y equals negative t squared. All I want is my rectangular equation with y and x, no t. Okay. So let's start with the horizontal. Remember, you can start with the vertical, but I recommend the horizontal. If we have x equals t plus 3, how would I solve that for t? There you go. So t equals x minus 3. Very, very simple. Solve one equation for t, plug the resulting expression, or I should say substitute, into the other one. Okay, so y equals negative t squared will just become negative x minus 3 squared. There you go. See, we have no t left. It's just an equation with x and y. This is my rectangular version. Now, we could rewrite this in standard form, the ax squared plus bx plus c. We could also write it in standard form for a conic. In fact, let's go ahead and do that because we just wrapped up our conics unit. There's only one change I would need to make, and it's in standard form for a conic. Can anybody tell me what that is? There's something that's out of place. Christian says that negative coefficient. So that would represent a coefficient. And basically, this form right here that it is now, you might recognize it like this. Ax minus h squared plus k. Does anybody remember what we call that form? This is something you would have looked at in algebra. Starts with a V. That is vertex form. That's vertex form, okay? So Christian is absolutely right. If I go ahead and divide this negative over, in fact, I'll even go ahead and plug a 0 in there. Now we have the standard form of a parabola in conics. We have my h, we have my k. In fact, the center, or excuse me, the vertex will be at 3, 0. What direction would it open? Up, down, left, or right?
Well, actually,
oh,
no, it's
down, because x is squared and the negative, right? So I have a parabola that opens down whose vertex is at 3, 0. Would everybody agree? Now, take a look at this. That's one of the first pairs of parametric equations that we graphed on Friday. In fact, when we graphed it, we got a parabola that opened down, vertex at 3, 0. Okay. Remember, graphing the parametric equations or graphing the rectangular form will be the same graph. It's just that the parametric is providing me a little more information that I didn't previously have. Okay. It'll allow me to find horizontal and the vertical distances. Did anybody recognize that pair of parametric equations before we started? Okay, well, let's try another one. Now, I'll go ahead and tell you that this next pair we did not graph on Friday. Now, the instructions might be different, if you go from teacher to teacher, resource to resource. Convert the following parametric equations to rectangular form. Okay, that's one way of saying it, or it could just say eliminate the parameter. Remember, t is your parameter. Basically, I want my equation with just x and y. I want the original equation. I don't want a t in there. So let's try this one. Okay. Again, you can start with the horizontal or the vertical. I recommend the horizontal. I would solve this first equation for t and then substitute. But let me give you a minute to take a look at that, and then we'll get somebody up here to go ahead and walk us through that process. Oh, this isn't on your notes. This is just an extra example I'm providing you. Mhm. 30 seconds. Remember, we're solving the x equals square root of t plus 1. We're solving that for t. And then we want to take the resulting expression, plug it into y equals t minus 2. Excuse me. Okay, so that's actually been over a minute. Who would like to come on up and show me what they have? Remember, your window of opportunity is getting smaller. 2 weeks from Friday is the end of school, and then I don't want anybody to be sitting there in the summer. I should have gone up to the smart board.
Wait, did we just write it with x and y?
All I want is the equation with x and y. Now, of course, you have to show me how you got there, too. Okay, support's coming up. All right. So let me erase this right here. Okay, there you go, sir. All right. So we have x equals the square root of t plus 1. So how do I solve that for t?
That's a y by the way.
Okay. Okay, so he decided to go with the vertical. Okay, that's perfectly fine. That's true. T would equal y plus 2. Okay, so he went ahead and took the other equation. He squared it. Okay, so I see what he did. So he says y equals x squared minus 3. That is exactly right. How many people got that? Perfect. Now, if you're not raising your hand, is there anything I can do? Is there a value? We're not sure where it came from. Okay. No. Jack, you okay? Okay, make sure. All right. Everybody's able to follow what he did here? No questions on that? Okay, fair enough. Then next up. Okay, we got one more before we'll return to that problem in your packet. Okay, so again, eliminate the parameter. I want a normal xy equation, no t. X equals 4 sine of t, y equals negative 3 cosine of t. So this is a pair of parametric equations for some type of graph, some rectangular form. Now this is different because we have trig functions here. All right. Now remember, the idea is to choose one, whether the horizontal or the vertical, solve it for what? Solve for t, and then you can use substitution, right? Well, because these have trig functions, like if I wanted to solve for this t right here, x equals 4 sine of t, how would I do that? How would I get t out from inside the trig function? You'd have to take the inverse trig function. Now, it is very possible to do it that way. I don't recommend it because it's going to get a little ugly. Okay, there's another way. I would encourage you to think back to your identities. Try to think of an identity that involves both sine and cosine that we can use to remove it. Okay. Now, because we're going to use an identity, let's go ahead and start here. Let's just solve each equation for the trig function. Like, for example, x equals 4 sine of t. what would sine of t equal? X over 4. All I need to do is divide out that coefficient, right? Okay. We'll do the same thing for cosine. What would cosine of t equal? Yeah, so y over negative 3, negative 1/3 y. Okay. Now, has anybody thought of a identity that could help me out here? Okay, Aiden, what do you think? That's exactly right. She's talking about a Pythagorean identity. Sine squared of t, and I'm just going to use t because that's what they have here, plus cosine squared of t equals 1. See, I have an identity that's using both sine and cosine, and I can replace it with something that does no longer involve a trig function. That's going to be very useful to me. The only thing is I have to what? I got to go ahead and square the two equations, but that's easy enough. Okay. I'm going to take this equation, square it. I'm going to take this one and square it. So sine squared of t, what should it equal? Oh, no, we're not on the other one yet. So what would sine squared equal? X squared over 16. Okay. And then cosine squared should equal what? Y squared over 9. Now you'll notice I didn't write these side by side. I went ahead and stacked them because we're about to do something with these two equations. We're going to go ahead and add them up. And this is, a perfectly legal operation because if you think back to systems, this was a given strategy for solving systems. Remember where two lines are going to intersect? Elimination. You guys remember that? So let's go ahead and add them up. Now these first column here, they're not like terms. So I'm going to say x squared over 16 plus y squared over 9. And see, because sine squared plus cosine squared equals 1, see now we have an equation with no trig functions. In fact, what did it turn out to be? It turned out to be an ellipse. Is the major axis horizontal or vertical? Okay, Jane, what do you think? It is horizontal. How do we know that? Oh, now remember, you know how it opens horizontally or vertically for hyperbola based on the positive variable. But remember, for an ellipse, you look for the variable that has the larger denominator. So I know A is 4, B is 3. I know the major axis is horizontal. In fact, look at this equation right here. X squared over 16 plus y squared over 9 equals 1. Again, on Friday, remember, we had previously graphed those parametric equations. And that gave me the exact parabola we got the equation for. A is 4, B is 3, centered at 0, 0. Okay. So remember, the parametric equations, those pair of equations will give you the same graph as the rectangular. It just provides us a little more information. Okay. All right. Well, let me go ahead and erase these. Okay. And now let's get back to this particular example in your notes. Okay. Now it says, notice that a parameter interval for t was not specified on the previous examples that we just did. Okay. When not specified, the implied parameter interval is all values for t, which produce real number values for x and y. Sometimes the domain must be restricted after converting from parametric to rectangular form. So this problem right here, I want to do the exact same thing that we were just doing on the previous ones. I want to eliminate the parameter. So I've got x equals 1 over the square root of t. I've got 1 equals t plus 1 over t. But the one thing I haven't mentioned up to this point, any values of t that we have to omit, that will carry over into my rectangular form. So basically, here's what we're talking about. My horizontal parametric equation right here, whatever the domain of that function is, the rectangular version has to have the same domain. For the vertical, whatever the range of that particular function is, that has to be the range of the rectangular equation that we're going to find. Okay, so let's go ahead and start here. Let me give you 2 minutes, okay, I want you to find the rectangular equation just like we have been on the previous example. So right now we're not worried about domain and range. Just do what we did on the previous examples. Get rid of the t. Okay? So 2 minutes. And you can start with the x equals, you can start with the y equals, does not matter, as long as you make sure that your rectangular form is y equals by the time you finish. Okay, 1 minute. My pen flip did not work too well. Try it. There we go. Okay, that's 2 minutes. It may not be done, and that's okay. But let's say I start with the horizontal. X equals 1 over the square root of t. How would I solve this for t? What should I do first? Okay, let's go ahead and square it. Okay, so this is going to give me x squared equals 1 over t. Okay, now what? Okay, so I'm going to multiply through by t times t, so tx squared equals 1. Okay, so x squared equals 1 over t. Oh, yeah, it's a Monday. I put it right back to where it was. T is equal to 1 over x squared. There we go. So there's my expression. Okay, good so far? Now, just like we did on the previous examples, I'm going to take 1 over x squared, and I'm going to plug it into every t for that other function. Okay. So y equals t plus 1. Let me give myself a little more room here. So y equals t plus 1, so that would be 1 over x squared plus 1, all divided by t, so that's, again, just 1 over x squared. Okay. Now, there's several different ways to go ahead and simplify this. Anybody want to tell me what they did? Okay. Dylan, what'd you do? Okay, multiply by the reciprocal. That's a great way because if I do so, you're going to have the numerator 1 over x squared plus 1. If you multiply by the reciprocal, that's just times x squared. You're going to end up with what? There you go. X squared plus 1, or 1 plus x squared, okay, but the order doesn't matter. That is my rectangular form. How many people got that right? Okay, so that's good. Okay, but now we do have a problem on our hands. See, if I plug in any value of x, there's no issues, right? Any value of x is going to give me a corresponding y value. But we have to remember where this equation came from. We got him from the parametric equation. So just looking at it straight, are there any values of t that we immediately can't have? We can't have 0. Okay, because 0. Oh, is that your phone?
Yeah.
Oh, okay. I mean, I thought it was my calculator. I mean, like, I'm worried about your phone, but I'm more worried about my calculator. So. Okay, so we're good. Okay, we're good. So like, for example, t can't equal 0 because these guys are undefined, right? So that means 0 can't belong to x squared plus 1. Also, I heard somebody say no negatives. What's wrong with a negative? Yeah, if you take the square root of a negative, it's going to go imaginary. So we want to avoid negative values of t. We can't have 0 itself. So what we're going to do, let's go ahead and graph these guys. Remember, if I know the domain of this graph, that's got to be the domain of the answer we found. If I know the range of this other graph, again, that has to be the range of that one. So we'll have everything we need. So let's see, 1 over the square root of t. So you're going to have to think back to your rational functions. So here's my x-axis, there's the t-axis. Okay, well, you said we can't have 0, so that'll give me what graphically? A vertical asymptote. Okay. Okay, so there's t equals 0. We can't have that. Now there's also a horizontal asymptote here. Where is it? It would be the x-axis. Can you tell me why?
Because you can't go below that, I'm guessing.
Well, can't have anything below, but somebody over here said it. There you go. You could rewrite this so that it's 1 over t to the 1/2. So the denominator's degree is larger than the numerator's degree, even though it's a fractional power. So in that case, remember, you were going to have a horizontal asymptote. Remember, one other thing, we're not worried about negatives. So if you were to do a little more analysis, you're going to see that would be our graph right there. Okay, 1 over the square root of t. Okay. Well, if we look at this graph, the domain here, it looks like it's values from what to what? How wide is this guy? Where would he start? 0 to what? 0 to infinity. And because of the asymptote, we can't include the 0. So I know because this is the domain of 1 over the square root of t, the horizontal parameter, this has to be the domain of x squared plus 1. Okay. So now let's do the same thing for the other one. This one is y equals t plus 1 over t. Well, again, we can't have 0 because it'd be undefined. So immediately we have a vertical asymptote. Okay. Where's my horizontal? Does anybody remember what case this is? Okay, Aiden, what do you think? Well, you had your finger up. So.
It's like the same.
Yes. Okay, so the degrees are the same. So what do I do when they're the same? Okay, remember we divide those leading coefficients. So here we also have a horizontal asymptote at, oh, excuse me, this one right here would be t, this is the y, so it's t equals 1. Okay, there we go. Now remember, from the previous parameter, we're ignoring negative values of t, so we don't need this other quadrant down here. But again, if you were to finish up our analysis, you're going to end up with a branch that looks like that. So we need the range of this graph. How tall is he? He goes from what to what? Okay, the range here, he goes from 1 to infinity, again with the 1 not being included because of the asymptote. All right, so let's take this information and let's go graph x squared plus 1. Okay, so I just went ahead and gave myself a pair of axes. So x squared plus 1 is just a parabola that's been shifted up 1, right? But we know based on the limitations from the parametric equations, he has to have a domain between 0 and infinity. He has to have a range between 1 and infinity. So what will that do to this graph? It's going to cut it in half. In fact, which half is gone? The left half. Remember, only from 0 to infinity. So I'm going to go ahead and cut this left half off based on my domain and range, but there's something else I'm forgetting. Aiden, you were about to tell me? Yeah, you'll notice the domain can't include 0 and the range can't include 1. So that means this point right here has to have an open circle. Okay. Now let's do a little bit of review very quickly. Let's say that I did want to go ahead and figure out what the orientation of this graph was. Well, first off, is everybody okay with what we ended up with? The rectangular equation, the graph, the domain range, any questions? Okay. How would I figure what direction the object is moving? Should the arrows be going up or coming down? How did we do that on Friday? Okay. So we need values of what? We need values of t, right? Okay. Now there are different values you can choose. Here's t, here's x, here's y. Just to go ahead and kind of make things go a little faster, I'm just going to choose values of t that are going to work nicely with the parametric equations we have. Let's say t is 1/4 and t is 1. Okay. T is 1/4 and 1. And see, that fits both of our values here. So if I were to go ahead and plug that in, I need another little line right here. Okay. If I plugged 1/4 into this one, x. So this would be 1 over the square root of 1/4. So it'd be 1 over the square, or 1/2, I should say. So what's that? 2. Okay. And then now let's plug 1/4 into y. Is everybody okay with what I'm doing? This is exactly what we did on Friday. Okay. So now I'm going to plug that 1/4 into y. So this would be 1/4 plus 1 over 1/4. Okay. So Christian was saying it was what? 1/5.
Oh wait, no.
5/4 over 1/4, right? And then now we're going to multiply by the reciprocal, so I should get 5. Okay. So see, I chose values of t. Okay, I started with the small one, gave me the 0.25. Now let's plug 1 in there. Okay, so what's 1 over the square root of 1? 1. Okay. And then now let's plug 1 into the other one. So that would be y equals 1 plus 1 over 1. So that is 2. So the order in which you plot those points, because I went from smaller to greater values of t, that tells me the direction. So we had a point here at 1, 2, 3, 4, 5. It was a little off, so let's say this one right here. And then 1, 2, this guy right here. So because this was the first, this was the second, it's going down, right? Okay. Now, is there anything else I need to change on my graph? Yeah, remember when I originally drew it, at the end here, I went ahead and put that arrow, so I need to at least take that off because of the orientation. Does that make sense? And of course, this graph is going to continue like that. It's just going to, there we go. All right, any questions? Is anybody having a hard time? Anybody not sure where anything came from? Well, because the object is moving. In order to get our distance, the object has to change position.
So it's all like
In a manner of speaking, what's happening here is that vertically it's moving to 1, and horizontally it's moving to 0. So like I said, I mean, right now we haven't really looked at any applications yet. We're just kind of looking at the basics. So I'm hoping it'll probably be Thursday when we're actually able to do our first application problem, or definitely Friday for sure. Okay. All right. Unless anybody has any questions, that is as far as first period and second got. So we will stop for today. Okay.